A massive antelope crashes through tall grass. A hunter crouches silently in the shadows. His weapon isn't a spear. It's a tiny arrow. The arrow strikes. Not deep, not fatal, just a scratch. The animal runs away. The hunter doesn't chase. He simply waits. Hours later, miles away, the giant collapses. The hunter walks calmly toward his prize. No magic, no luck, just chemistry, and perhaps the most sophisticated biological weapon technology of the Stone Age. Because 60,000 years ago, long before laboratories, textbooks, or written language existed, humans had already discovered something remarkable. You don't always need to kill an animal immediately. Sometimes, all you need is time. This is the story of the poison arrow, and how ancient hunters became some of humanity's first chemists. Imagine you're a hunter living tens of thousands of years ago. You have no metal, no firearms, no domesticated animals, no traps powered by machinery. Yet your survival depends on hunting creatures that outweigh you by 10, 20, or even 50 times. A wounded buffalo can gore you. An antelope can outrun you. A giant prehistoric animal can simply absorb a non-lethal wound and keep moving. For early humans, hunting wasn't merely difficult. It was extraordinarily dangerous. Every confrontation carried the possibility of death. The challenge was simple. How do you bring down a massive animal when your weapons are relatively small? The answer was revolutionary. Don't make the weapon stronger. Make the wound smarter. Instead of relying on immediate damage, ancient hunters learned to exploit biology itself. Their weapon would continue working long after the arrow had left the bow. One of the most remarkable intellectual achievements of prehistoric humans wasn't a tool. It was an idea known today as delayed causation. Most animals understand direct cause and effect. Strike something and it moves. Drop something and it falls. Immediate outcomes are easy to observe. But poison introduces a completely different chain of reasoning. Imagine discovering poison for the first time. A hunter notices that a particular plant or insect causes sickness. Perhaps an animal eats it and later dies. Perhaps accidental exposure produces strange symptoms. The effect doesn't happen immediately. Minutes pass. Hours pass. Sometimes days pass. To connect cause and effect across such long stretches of time requires advanced cognitive abilities. The hunter must understand, what I do now can produce consequences much later. This sounds obvious to us, but it represents a profound leap in abstract thinking. It's planning, prediction, experimental reasoning, the foundations of science itself. Ancient hunters were not simply using poison. They were thinking like researchers. Across Africa, Australia, Asia, and the Americas, indigenous peoples discovered hundreds of natural toxins. Many came from plants rich in powerful chemical compounds known as alkaloids. Alkaloids are naturally occurring molecules produced by plants as defensive weapons. To the plant, these chemicals discourage predators. To humans, they became tools. Some alkaloids attack the nervous system. Others stop the heart. Some interfere with muscle function, eventually causing paralysis. Ancient hunters learned which species contained useful toxins. They harvested roots, leaves, seeds, sap, sometimes even beetle larvae. The ingredients were crushed, heated, fermented, concentrated, and mixed into deadly preparations. This wasn't random experimentation. It was practical chemistry. Different toxins produced different results. Some worked quickly. Others acted slowly. Some were ideal for large animals. Others were more effective against smaller prey. The poison wasn't simply smeared onto a weapon. It was engineered for a purpose, a prehistoric chemical delivery system. The poison arrow itself was a masterpiece of efficiency. The arrow didn't need to penetrate deeply. It didn't need to break bones. It didn't even need to cause major bleeding. All it needed was access, a tiny opening in the skin. Once the toxin entered the bloodstream, Biology took over. The animal might continue running. It might seem unharmed, but inside, the chemical battle had already begun. The hunter understood something crucial. The poison was doing the chasing. Every step pumped the toxin farther through the body. Every heartbeat accelerated its spread. Instead of risking a dangerous confrontation, the hunter transformed the prey's own physiology into a weapon against itself. The strategy conserved energy, reduced risk, and dramatically increased hunting success. This wasn't brute force. It was systems thinking, a sophisticated understanding of how multiple processes interact over time. Perhaps the most astonishing part of this story is not the poison itself. It's how the knowledge survived. There were no books, no universities, no laboratories, no written instructions. Yet some poison arrow traditions persisted for tens of thousands of years, generation after generation. For roughly 2,000 generations, humans transmitted highly specialized biochemical knowledge entirely through memory, observation, and teaching. Think about that. A child learns which plant is safe, which plant is deadly, which season to harvest, how long to prepare the mixture, how much poison to apply, how to avoid poisoning themselves. One mistake could be fatal, yet the knowledge endured. This required teaching systems of extraordinary reliability, stories, demonstrations, apprenticeships, rituals. Oral traditions became living libraries. Every elder was a database. Every generation was responsible for preserving information critical to survival. Long before written science existed, humanity had already created an effective system for storing and transmitting complex technical knowledge. Modern people often imagine prehistoric humans as primitive, crude, unsophisticated. But poison arrows tell a different story. To create an effective poison hunting system, humans needed botanical knowledge, chemical knowledge, ecological knowledge, animal behavior expertise, long-term planning, experimental observation, and social systems capable of preserving information across thousands of years. That's not primitive thinking. That's advanced cognition. The technology may appear simple. The ideas behind it were not. The poison arrow reveals a truth that archaeologists increasingly recognize. Ancient humans were every bit as intelligent as we are. What differed was not intelligence. It was access to accumulated knowledge. The minds that developed poison arrows were capable of remarkable innovation. They solved problems using the tools available to them, and in doing so, they laid the foundations for humanity's long journey into science and technology. The next time you picture Stone Age hunters, don't imagine people stumbling through a primitive world. Imagine chemists, biologists, engineers, experimental researchers. Imagine a hunter releasing a tiny poisoned arrow into a massive animal, not relying on strength, not relying on speed, but relying on an invisible chain of chemical reactions unfolding inside a living body. That hunter understood something profound. Sometimes the most powerful weapon isn't force, it's knowledge. And 60,000 years ago, long before humanity built laboratories, we had already learned how to turn nature's chemistry into one of the most effective hunting technologies the world had ever seen.